All right, so guys, this is a homework problem from, let me see, 3.1. Okay, so it's 3.1825. Okay, it says find the length of a 75-degree arc of a circle whose radius is 5. Okay, so for part A, let's do part A. We know that our angle theta is going to be 75 degrees, and the radius of the circle is 5 centimeters. Okay, so just so we get a visual of what we're doing here, this is 5 centimeters, right? And, oh, I don't know, I'm gonna go right here. This is also 5 centimeters. And this angle here is 75 degrees. Okay, so first thing I'm gonna do, I have the formula written right here. Guys, I took this directly from our notes from 13.1, okay? So the formula here says L equals R times theta over 180. Okay, so I'm gonna write that down. L equals, oops, sorry, I forgot it. Pi r theta, what is it, over 180? Yes, over 180. Okay, and so now we're just gonna do a little plug and chug. So we're gonna take pi, r was what, 5? Theta was 75 degrees, and this is all over 180, okay? So I'm going to take my calculator. I need to figure out what's 5 times 75. Okay, so let's figure this out. Let me clear all this. 5 times 75 is, now we can divide it by 180. 2 and 1/12. So I think, guys, if I hit fraction button again, there we go. It gives it to me as an improper fraction. So 25 over 12. Don't forget, we still have the pi thing there, okay? So this is going to be 25 pi all over 12. And that's why they wrote that right there. Okay. Now, there is a part B. So let's see if we can figure out part B. Part B says, explain why the length in part A is longer or shorter in centimeters than if the radius had been 9 centimeters. So here it tells me that the arc has to be longer because 9 centimeters is greater than 5 centimeters and the radius is in the numerator, okay? And so then now they're saying, okay, look for part C. So part C says, well, suppose we had a new circle where the radius was now 9 centimeters, okay? 9 centimeters. And the length here, my angle was still 75 degrees for that angle. Now, if we wanted to find the length, we could say we're going to use the same formula. And the only thing that's going to be different now is that instead of a 5, we're going to have a 9. Okay? And so again, I'm going to do the same thing I did in my calculator. I'm going to take 9 times 75, and we're going to divide that by 180. And if we want to make that into an improper fraction, we're just going to hit the fraction button. 15 over 4. Don't forget, we still have the pi. So this is going to be 15 pi over 4. And so that is going to be my answer for part C, okay? And so we're saying that this number here is bigger than that number there, okay? So guys, this is just, I mean, we've already done the problem, but this is just to kind of show you why those two numbers, why this number is bigger than this one. Okay, so I'm going to just show you this here on the side. Remember the first number we had was 25 pi over, not 4, but 12. Oops, sorry. 12, right? Okay, now the next number we have is 15 pi over 4. In order for me to compare these two numbers, I need to get the denominators to be the same. So the common denominator between 12 and 4 would be 12. So I want you to notice something. If I multiply this by 3, that's going to be a 12. But then I got to multiply this one by 3 as well. So the first one still stays as 25 pi over 12. This one, I know in the bottom, 4 times 3 is 12. 3 times 15 is 45 with a pi. When these two numbers are the same, then we can do a comparison with the top. And 25 is smaller than 45, right? That's how I know that this number here is bigger than this number over there, okay? Anyway, hope that helps. If y'all got any questions,